We're going to continue with the review section here. We're talking about the fundamental theorem of calculus. It's in two parts. The first part is relating integration to different. Try that again. We're picking up on our notes here with the fundamental theorem of calculus in two parts. The first part is going to take integration and relate it to differentiation. It says if a function f, lowercase f, is continuous on an interval, then there's this other function, capital F of x, where that capital F of x is equal to the integral of that first function. In other words, you can find the answer to an integral by working backwards from what we learned with differentiation. So for instance, if you had this function capital F of x equal to x squared, and you were asked to find the derivative of it, you would get just 2x. Working backwards, if you were asked to integrate, you would get back to your x squared. So it's relating these two parts of calculus, integration and differentiation. The second part of that fundamental theorem of calculus tells us how we can evaluate over an interval. And it says if you are integrating the function lowercase f over the interval a to b, it's going to be that capital F function, we're working backwards, its value at b minus its value at a. So going back up here, if I was looking at the integral of the function 2x d of x from, let's just say something simple, 0 to 1, we know that the value of capital F of x is x squared, so I'd be looking at the function x squared at 1, and then x squared at x equals 0. So I'd have 1 squared minus 0 squared. 1 minus 0 would be 1. And that's the fundamental theorem of calculus. From this fundamental theorem of calculus, we're going to be able to integrate a wide variety of functions. And this leads me to a property that we're going to use repeatedly. And it's kind of a generalized property, something I mentioned earlier. Anytime you are integrating x to the n power, you can find the answer by taking x to the n plus 1 power over n plus 1. Okay. When you integrate that, it's just x to the 1 higher power over that higher power. And that's going to make life a lot easier as we work through a lot of these integrals. In fact, we're going to use that for the first one here. It says evaluate the following integrals. The first one is the integral from 1 to 4 of 3x squared minus x cubed over 4 dx. You could think of this as two separate integrals if it helps you. I won't do this all the time, but here in this first review section, I'll go ahead and write them as two separate integrals. So it's the integral from 1 to 4 of 3x squared minus the integral from, and I forgot my dx there, minus the integral from 1 to 4 of x cubed over 4 dx. With the first one, that 3, you could put that in front. So you'd have 3 times the integral from 1 to 4 of x squared dx. In the second one, that 4 in the denominator, you could bring that in front as a 1/4. The integral from 1 to 4 of x cubed dx. So before I bring this off the screen, we're just going to use this here. When we integrate x squared, we get x cubed over 3, and we're going to evaluate that from 1 to 4. On the other side, when we integrate x cubed, we get x to the 4th over 4, and again from 1 to 4. Now, 3 times x cubed over 3. I can take the 3's and cancel them. So now we're just looking at x cubed from 1 to 4. So it's going to be 4 cubed minus 1 cubed. Then moving over to the second parts, I've got a 1/4 in front and then the 4 here. I'm going to combine those and make it a 1/16. So we have minus 1/16 times 4 to the 4th minus 1 to the 4th. So 4 cubed is 64. 1 cubed is 1. Minus 1/16 times 4 to the 4th, which is 256. Minus 1 to the 4th, which is 1. You can already see we're going to end up with a fraction over 16 here. So I want to go ahead, 64 minus 1 is 63, but I'm going to end up writing that as a fraction over 16. So the number 63 ends up becoming 1008 over 16, just creating that fraction. So now the other part, 1/16 times 255. So that's going to be the fraction 255 over 16. And then subtracting, it's not going to be a pretty fraction, but we do get the answer, 753 over 16. So some of them are relatively straightforward. Here we're just using this bit of information to help us with the integration. Sometimes you're going to have integrals that you need to evaluate with trigonometric functions in them, and sometimes you're going to have to use some trig properties. So this next one here is the integral from pi over 2 to pi of sine 2x over 2 sine x dx. What I'm going to first do is use one of the properties in trig. Now, please don't worry if you don't have all of these memorized, and if you need a refresher, it's fine. In the Start Here module in BlazeView, I do have a sheet with these trig properties. So you can go back and look at that sheet if you need a refresher. But one of those properties says sine 2x is equal to 2 times sine x times cosine x. And I'm going to use that property here. Go ahead and replace the numerator. And that's going to allow me then to cancel out the 2 sine x in the numerator and denominator. So all we're now left with is cosine x dx. If you remember, if you take the derivative of the sine function, you get the cosine function. So when we're working backwards, the integral of the cosine function is going to be the sine function. So we end up with sine x, and we're going to evaluate that from pi over 2 to pi. Sine of pi is 0. Sine of pi over 2 is 1. So we have 0 minus 1, or negative 1. And that negative area indicates that it's under the x-axis. The third one here, you might be looking at this saying, can't quite remember what to do here. This is going to make use of the inverse. If you were asked to differentiate the inverse sine function, you will end up with 1 over the square root of 1 minus x squared, which looks somewhat familiar to what we have here. This is another one. You may not have this one memorized, but again, in that Start Here module, I do have a lot of the more common and some not so common derivatives, and you can go back and use that sheet as a reference. So the only thing different in the integral that we're looking at is we have this 4, but you can just put that in front of the integral. So we're looking at 4 times the integral from 0 to 1/2 of 1 over the square root of 1 minus x squared dx. So now we have this. When we integrate, we're just going to get the inverse sine of x. We're going to look at that from 0 to 1/2. So we have the inverse sine of 1/2 minus the inverse sine of 0. The inverse sine of 1/2 is going to be pi over 6, 30 degrees. And the inverse sine of 0 is 0, so we end up with 4 times pi over 6. And 4 pi over 6 is the same thing as 2 pi over 3.